Okay, so for today, we're going to talk about complete combustion, incomplete combustion, and we are going to compare the two. So before we jump into that, I do want to start off with defining what combustion is. It's basically when a compound reacts with oxygen. And the end product of that is energy. So oftentimes, the energy is released in the form of heat. It can also be released in the form of light. An example of this is when you have a burning log of wood. This is a great example because when we talk about the wood is actually what you would call like an organic material. It contains lots of carbon, lots of hydrogen. So when it reacts with oxygen, it produces water and it also produces lots of different types of products. And the products we produce actually depends on how much oxygen we have. So it depends on how much oxygen is present. That's when we can start talking about complete combustion and incomplete combustion. So just jumping into complete combustion, this is what happens when there is an abundance of oxygen. And by that, I mean you have loads of oxygen and it's reacting with like some type of organic material. The simplest one I can come up with is, let's say you have methane, which is CH4. And then if this one reacts with oxygen and there's actually extra oxygen, so there's an abundance of oxygen, you end up producing carbon dioxide and then you also produce water. Notice that both the hydrogen and the carbon get oxidized in this scenario. And just to go ahead and balance this reaction, I would put a 2 in front of oxygen and then I would put a 2 in front of water. So almost always in combustion, water is produced without an issue, but then the level of oxidation for carbon really varies. But then this is the most oxidized state for carbon in this scenario. And by that, I'm referring to carbon dioxide. But then you also have another scenario called incomplete combustion. As expected, this is what happens when you have a scarcity of oxygen. And so I'm just going to pause here to do a little bit of a breakdown, just talking about the levels of oxidation for carbon. So the most oxidized that we're dealing with here is carbon dioxide. So each carbon gets 2 oxygens. And then if there's less oxygen, you get carbon monoxide. And then if there's even less, then you just get plain carbon. And we actually call plain carbon in this scenario, we call it soot. Okay, so going back to that description, so let's say you have methane once again. So if I have methane and it's reacting with oxygen, but there isn't that much oxygen, then I'm just going to say less oxygen. Then this will still end up producing water. Almost always because the hydrogen gets oxidized first, then whatever is left of the oxygen goes towards the carbon, which is why we have varying products for the carbon. So in this scenario, you might end up producing something like carbon monoxide because there's less oxygen, and then you would still produce water. In this case, energy is still produced, so take note of that. Energy is still produced, but then it's less energy that's produced compared to the complete combustion. so less energy is produced. So less oxygen present means less energy produced in the grand scheme of things. If I wanted to balance this, then let's give that a try. Carbon on one side, carbon on one side, that's all good. You have two hydrogens, or you have two hydrogens on the product side, but you have four on the reactant side. So I'm going to go ahead and put a 2 over here. So carbon is balanced, hydrogen is balanced, but then the oxygen is not balanced because you have 3 oxygens on the product side, but you only have 2 on the reactant side. So to combat that, I will do 3 over 2 in front of the oxygen. And this is because 3 over 2 multiplied by 2, that gives you 3, so you get 3 on both sides. So this is a balanced reaction. If you are really picky, you can go ahead and multiply the whole reaction by 2, just so you get whole numbers. But I'm just going to pause here. So in this scenario, everything is balanced, but then the product that you get for the reaction in incomplete, you're going to get a carbon monoxide, which is less oxidized than a carbon dioxide, and this is a gas. Carbon monoxide is a gas, and it's a toxic one at that. Okay, this is one scenario, but then another scenario is, what if I produce soot? What if I produce just carbon? Well, let's look at that scenario. In that case, I would have methane, so CH4 plus O2. This is a gas, this is a gas. All of this reacts to produce, in this case, you're going to get carbon plus water. The recurring thing is that water is produced. So in this case, this is when you have the least amount of oxygen present. So in this case, it's like even less energy produced. Okay, so we can go ahead and balance this one. Carbon, carbon, hydrogen, you have 4 on one side. I put a 2 already, so we're all set. Okay, and a lot of the time, because combustion reactions are pretty hot, you produce a lot of, you produce a lot of heat. Most times the water ends up getting produced in the form of water vapor, which is a gas. Methane is also a gas. Carbon dioxide is a gas, carbon monoxide is a gas, but then soot, which is that black powdery substance you see sometimes in the air, especially if there's like a lot of pollution, that is a powdery solid, which is different. So this is going to be a solid. This is one scenario for incomplete combustion. That's not to say you only produce carbon dioxide, or sorry, you only produce carbon monoxide, or you only produce carbon. Sometimes you get mixed products. So there are some scenarios where you will go through an incomplete combustion and you end up producing lots of different products, because that's what happens in reality. You get some carbon dioxide, you get some carbon monoxide, and you get some carbon. So let's talk about a scenario like that. Let's say that I have propane. And propane is, let me get my pen, C3H8. And that reacts with oxygen in a combustion reaction. And I can produce, if there's not as much oxygen as we would like, you would produce CO, carbon monoxide, and sometimes you produce carbon soot, and you will still produce that water. This is actually something that could happen. So if I wanted to balance this, I can put, so I have 3 carbons on one side. It's usually easy to add more carbons to the thing that only has carbon. So I'm going to put a 2 on this side over here so I can get 3 carbons on the other side. In terms of H, you have 8 H's on one side And so I'm going to put a 4 in front of H2O. And then that leads to us having 2 oxygens on one side. And then you have 4 oxygens on the product side coming from water, and then 1 oxygen coming from carbon monoxide. So that means I have 5 oxygens on the product side. If I wanted to balance this, I could just put a fraction. I could just put a fraction of 5 over 2 so that I end up having 5 oxygens on the reactant side, because 5 over 2 times 2 is 5. And I also have 5 oxygens on the product side. Again, if you want to have whole numbers, you could multiply the whole reaction by a 2 so that you get whole numbers for everything and get rid of that 5 over 2 fraction. Either way works. The main takeaways are that you have complete combustion, which happens in an abundance of oxygen, and that produces the most amount of energy, so usually the most amount of heat. And then you also have incomplete combustion, which takes place when there's really scarce amounts of oxygen. That leads to you producing products that are even less oxidized. So generally you have 3 possible carbon products. It can be carbon dioxide, it can be carbon monoxide, or it can be carbon. And keep in mind that this combustion is true for a lot of hydrocarbons, things that have both carbon and hydrogen. It could also be the case for alcohols as well, so things that have that OH group.